Hi everyone, welcome to Engineering Takeoff. In this video, we are understanding types of relations and functions. For better understanding, watch our previous video, link will be in the description. Without any further delay, let's dive and understand types of relation. Under types of relation, we are understanding reflexive relation, symmetric relation, antisymmetric relation, transitive relation, equivalence relation, partial order relation. Let's see one by one. Reflexive relation. Relation R is said to be reflexive relation if every element of set A is related to itself. For example, consider set A which contain element 1, 2, 3, and reflexive relation must always contain order pair 1, 1, 2, 2, 3, 3 with or without other order pair. This kind of relation is called as reflexive relation. To find total number of reflexive relation that can be formed from element set A is 2 to the power of n minus 1, where n is the number of element in set A. So 2 to the power of 3 minus 1, we get 2 to the power of 6, which is equals to 64. So using set A, we can form 64 reflexive relation, symmetric relation. A relation R is said to be symmetric relation if A is related to B, then B must be also related to A. Let us take an example. A relation R contain order pair 1, 2, 1, 3, 3, 1 and 2, 1. This relation is symmetric relation because it contains 1, 2 and also contain 2, 1. Similarly, a relation contain order pair 1, 3 and it also contain its inverse 3, 1. Let us take another example. A relation contain 2, 1, 1, 2, 1, 3. This is not symmetric relation because it does not contain 3, 1. Basically, a relation must have its inverse order pair in it, otherwise they are not symmetric relation. And another important formula to calculate all the possible symmetric relation that can be formed from set A. If set A contain n elements, then to find possible symmetric relations is to the power of n plus 1 divided by 2. This will be helpful for objective. Antisymmetric relation. A relation R is said to be antisymmetric relation if it does not contain inverse order pair when A is not equals to B, but it can contain when A is equals to B. Important note about antisymmetric relation. A relation which is not symmetric need not to be antisymmetric. Let us see some example to understand antisymmetric relation. Consider set A which contain element 1, 2, 3, and here we have three relation R1, R2, R3. In R1 we have 1, 1, 1, 2, 1, 3. R1 is antisymmetric relation because it does not contain inverse of 1, 2 or 1, 3, and antisymmetric relation can contain order pair with same element. So R1 is antisymmetric relation. R2 contain inverse of 1, 2, that is 2, 1. So it is not an antisymmetric relation. R3 contain order pair 1, 1, 2, 2, 3, 3. Antisymmetric relation can contain the order pair contain same element. So this is antisymmetric relation. Transitive relation. Relation R on set A is said to be transitive relation if A is related to B and B is related to C. Then A must be related to C, where A, B, C belongs to set A. Let us solve few examples to understand transitive relation. Relation R contain order pair 1, 3. 1 represents small a, 3 represents small b, and it also contain 3, 4. 3 represents small b and 4 represents small c, and it contain 1, 4, which means 1 represent small a and 4 represent small c. As per the definition, A is related to B, B is related to C, and A is related to C. So this relation is transitive relation. Similarly, for relation R2, we have 1, 3 and 3, 2. 3 represents small b and 2 represents small c. It contains order pair 1, 2, where 1 represents small a, 2 represents small c. This relation also contains order pair AB, BC and AC. So R2 is transitive relation. Next example, R3. It contains only two order pair. So by seeing itself we can make out it's not an transitive relation. Last example, relation R4. It contains 1, 2. So A, B. A represents 1, B represents 2. It contains 2, 4, B, C. 2 represents B, 4 represents C. And it contains 1, 4. 1 represents A and 4 represents C. This relation contains order pair A, B, B, C and A, C. But it also contains another order pair 4, 5. It does not contain order pair 5, X and 4, X in this relation. So this relation is not transitive. Equivalence relation. Relation R is said to be equivalence relation if relation satisfy reflexive, symmetric and transitive condition. Let us take an example to understand equivalence relation. Relation R contain order pair 1, 1, 2, 2, 1, 2 and 2, 1. This relation satisfy reflexive condition because it contain 1, 1 and 2, 2. This relation also satisfy symmetric condition because it contain the inverse of 1, 2 that is 2, 1. And last condition is transitive. So relation contain 1, 2, 2, 1 and 1, 1. In another case it contain 2, 1, 1, 2 and 2, 2. So by this we get to know a relation R satisfy all three conditions. So this relation is equivalence relation. Next one is partial order relation. Relation R is said to be partial order relation if relation satisfy reflexive, antisymmetric and transitive condition. From definition we can easily get partial order relation is same as equivalence relation, but small change is it should satisfy antisymmetric condition instead of symmetric condition. These are the types of relation. In next video, let me understand types of function. Thank you for watching. Please subscribe, like, share. Click on bell icon for further update.